Hey, welcome back to my never-ending whatever journey to fix that motor here or the carburetors of the GL1000. So I just recap, I made actually a drawing of that last slide, the only slide who survived, and now I measured it as well. I put it on the scale and see how much it weighed. It weighed 2.4 ounces. So next slide when I make them, it has to be at least close to that. And you saw me in the first video making this or taking it out of one of the old slides. And I found out actually that this is the main part of the vacuum sucking the piston up and pretty much up, down it goes by itself with the spring. So these vacuum piston, whatever they call it, is important but not that important to drive the bike. So it doesn't run very well, but it will run, and that's probably why that machine was still running. So I jawed up my stuff. I'm going at the machine and let's see how it will go. All right, I don't know, lots of people maybe know CNC machines, some people might not know anything about it, so I'm taking the liberty here to explain a little bit. This is kind of a semi-automatic manual. I can crank handles here, not so fast handles, and I can move my machine around, or I can use the machine and chalk it any way I want to, plus, minus. So you have all the axes in a machine, like in a Cartesian coordinate system. Anybody paid attention in school, they might know that. And the machines are basically, they know nothing. They just know how to put voltage on the little servo motors and move them, and then there's an encoder says, hey, stop, I'm right here at the point where you want to go, and then it moves to the next point which you program in that Cartesian coordinate system. Now I'm like Joe here, friends. And so when I start something like that, or in any other machine, doesn't matter if it's a mill or whatever it is, you have to have a datum from where everything is calculated on. So on this machine, doesn't know nothing where I am. It's kind of, so I have to tell them, where's my datum here? If it's the front of the part, the back of the part, anywhere in space here. So what I have to do is I have to start my engine here, or in this case, the spindle, and then touch it off a little bit till you see a little bit of it. But don't be so fast with your gizmo. So it's scratching a little bit here, as you can see. Stuff flies off, little chips. And then I have to tell the machine, hey, make that 0. But since the machine is stupid and I'm right behind it, it says, hey, tool 1. It thinks tool 1 is in there, and I don't have tool 1. This is tool number 4. As you can see, I marked it so even I know it. So I have to first call tool number 4 to make sure the machine knows exactly where that tip is in the machine space. So let's say T0404, and like I said, the machine is, I called it tool number 4, but I have to tell it, hey, I want an offset for tool number 4 too. And then when I call it, it tells me, hey, install tool and press cycle start. And all the controls are kind of similar.
What's an offset?
An offset is where you write your offset in relations to your machine coordinate system. So when I look at the offset here, in my work offset 0, it writes in exactly where my datum is in the z-axis in this case, relation to, usually most of them is the spindle nose. In this case it's from here because I touched off my tool on here on the chuck. So I just call it Z phase measure, and now it knows, oh, that's where 0 is. So I know, and I can show you that quick here. Get rid of that one, say G54. That means it's my coordinate system I want to call. G0, which means go as fast as you can, and then Z0. And here it is. In the meantime, I move my tool away here a little bit, and then I hit engine start or machine start. Maybe starting. It goes to that point which I just told them is Z0. And in this time probably I lost about 90% of the viewers. And X is already in there because that doesn't really change. Diameter doesn't change. The only thing on the lathe changes is pretty much the Z. It's different when you have fully automated lathe with turrets, 2 turrets, 3 turrets, and all kinds of other things going on, slide stock, and you have tons of shit going on. And you need a little bit of a different approach to it than with a simple 2-axis lathe here, X and Z. So I set my datum here. I said it's cool. I wrote a little program to rough that baby out. It should be in my USB, but unfortunately it's here in my pocket. There's a slide, turn 1, select the program. So from here on it's just pretty much hit the start. I have an offset in X. When you machine something, sometimes it's not the right size. You put a little bit diameter offset on there. I want to put a little bit a plus on there because I don't know if the machine grows, or it's kind of cool today, so it might be a little bit more shrinkage.
Significant shrinkage.
So okay. Shrinkage. All right, let's see what's going on here. Hit NC start. And let's see what's going on. I slowed it down. Okay, roughed it all out. That's how the original looks. And when you see, it comes pretty close already to the new slide. So let's continue. Let's put a hole in there, and to make sure the hole I drill will be in the center of the part, I do a center drill operation here. And now I drill a hole here, 9.5 millimeters. So I have a little bit left to finish it up. Now it's time to finish the OD. And let's see what we come up with here. Don't do that. All right, so now I have to see. This is my piston. I designated A1, so it fits to the carburetor A1. They're all a little slightly different, and I want to make sure I just copy exactly what it came out of it, because apparently that worked at one time 50 years ago. So this is 31.348 millimeters, not inches. Let's see what this is here. This one is 31.652 and the other one is 348. So I can go at least another 300 micron before I measure again. And here we go. A little bit of loopy doobie 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 doo. Okay. Okay, 399, 398, and 98, 357 or so, what it was, or 355. So 40 microns, and that's the end of it. And go. And the only thing I do here on the machine, I put an offset on it. I tell the machine that tool is either longer or shorter. Again, don't do that. I can do it. I do it for 40 some years. And I cut myself many times too.
This is the guy that did it for 45 years that lost a finger.
That's right. It's just habits, you can't help it. I only do it with aluminum, not with anything else. Or plastics, so it's fine. So now I polish it up a little bit with a 2000 grit papier. Okay. And don't do that either. Okay. One more time, final measurement. 31.358, just exactly like the other one. Microns. Okay, now we do the hole. Okay, let's do the holy grail hole. Okay. Change the offset a little bit, make it minus 0.1. And go. A little bit of weasel piss. Whoa. hole for the inside, and this one I took out before when I machined it in the first video, and it measures I think 10 point what's going on, 10.062. so to make the hole perfect, so this one if I heat up the slide and cool that down a little bit so it fits nicely together, I take my notes from the European ISO tolerance system. They've dedicated everything in a way that things fit together. You have a tolerance fit which is loose, which is a play, and you have a tolerance fit which could be loose and really hard to get in, and then you have one which goes hard and you have to press it in also or heat it up or whatever. And I choose, in my case, I use for my shaft, which is 12 microns, 3 to 10 is 12 microns over. This is so 60. So H7 would be this, and then S6. Unfortunately, I don't have that in my stupid book here, but S6 is pretty much 30 microns under that size. So I have to make my bore 10.03 maximum to fit in there. I can go up to 10.045. That's the tolerance which gives me the S6 category. So let's do that and see if we can get it shrunk in after it's done everything. 9.9, perfect. So let's come close to what we need. 7. Oops, wrong memory. Come on. Let's see if I can take my dial bore gauge now. Never enough room. When you see here, unfortunately I'm mixing inches now with millimeter. This is 1/1000 and 2.5 tenths, which is about 27 microns or so. So let's take another 1/1000 out and see where we're at. Perfect. 1 millimeter, 10 millimeters, and 1/10. 1/10 is what? 2 microns or so, 2.5 microns. Okay, dokie, let's put the grooves in. That's what it is. There's some grooves in there. Okie dokie. That's it for the turning operation. Just put a couple of That's always a lot of fun for the kids. Maybe I should measure, but Plenty of room there, I think. Okay, let's. Coming close, slowly. Looks like that. Soon.
A minute, please. I have them lined up and
Camera people are too demanding. And that would be carburetor A, hence the slide AA, A1. Oh yeah, perfect. I think now it's time to mill a couple, whatever, milling passes, hawk the inside out, put the little, whatever, half round, half pipe in there in the front, and a slot. And that would be the end. So let's go to the milling machine. Okay, we're at the mill right now. We want to mill all the features on the piston here, like the little dish or half pipe, drill the holes and do the rest. So I start on the side where we have that dish here, put my 3 holes in there, put the little half pipe in there, and then I flip it around and I do the inside, and then I later on I do the slot. So let's set it up. That machine is pretty fancy. I got a probe in there, like on a coordinate measuring machine. So I can go and touch things up fairly easy. The machine, the probe pretty much probes the location and sets the datum, in this case in the center of the bore. And my Z-axis needs to be set as well. I say the top of the part, and that's it. Set datum and now we can start rock and roll. I had to set the tools up and everything, so, and make sure everything is kosher. So let's go and drill some holes. All right again. Man, oh man, I have to learn a new word here. Okay, this is done here now with a little gizmo in the center here, half pipe, whatever you want to call it. And here you see the original. Done. So now I have to turn it around and do all the inside here. Okay, I put the dish on the other side. Now I'm doing the back side of the slide, and I drilled all the way the holes through because I want to have some reference point so I can line it up with the slot on the bottom or the half pipe on the bottom. So that hole is important. That's the one in the y-axis in 0. So I have to line it up here. And that's the beauty on a 5-axis machine. So you can do things like that. Alright, that was close. Okay, the machine tells me it is 3.4718 degrees out of alignment with the x-axis. So 3.4718. It was plus, so I have to go in plus. Let's see what it does. Lined it up. Now I have to set the datum. And I use the outside. Now I want to just check out if that hole is actually in Y0. Check once, check twice. Okay, it's 31 microns off in the center. I'm really not... I should actually lose sleep about that, so... And let's do that again. Sure enough, it's not in the right position. It has to be 90 degrees off. Minus 90. And then I have to and now we have to set the datum again new. It's not for punishment. Okay, the last thing we have to do now is put the little slot into the slide, the one which actually keeps it from rotating, anti-rotation slot. And after that one, this is all done, and you should have to have a nice finished slide. Okay, that was pretty much it with machining the slide. Here it is. Here's the original. So
Looking good. Nice and shiny.
nice and shiny, yeah. So now that one has to go in the carburetor number A, and that goes nicely in here, and it should go nicely in here. I can see it pulling some vacuum when I pull it out. So the next thing I have to do on this one is I want to measure it actually. Let's see how much it is here. Where's my, should be 2 point, yeah, with the other piece. What is 2.4? Oop, perfect. 2.4, 2.4. Check it again one more time. 2.4. So I'm good that way. Now I will heat up my piston and put a little bit of cold on here. I don't want to put too much on there because of I don't want to have the chrome start separating from the brass here, so but a little bit of cold is okay. And then I just drop it in, and this slide is done. Alright, I talked to you when I set everything up to heat and freeze, and then we do the last step, and unfortunately I have to do 2 more. So it's not very, how you call it? No, usually when you do one thing, you do right away all the operation, all of them. Otherwise it's kind of a waste of time, but I don't want to let people hang around there, and I have to do other stuff as well. So let's see, next time, next minute or 2, I will finish that up. Just using some freeze spray here to freeze the part. And now we can wait here till it comes back. Fingers.
You're sizzling.
All right, insert it. Now we just need to cool it down a little.
Do you let it just go by room temp? Cool down at room temperature?
No, I take it into the sink, cool it down a little. So I can, I'll be back in a sec.
Did you have to make your own little tool there to pound that in?
Yeah. But I want to hit the end of it. with the hammer.
Understandable.
So here it is. A little dirty for my glove was dirty. But already should go in here. Good. And then this one. Oh, that's
You did the wrong one.
No, that was the right one. That was just really dirty inside. Needs to be polished out a little bit. That's it.
And probably needs to be dipped in the
Yeah, it needs to be cleaned up.
a hot tub action.
Hot tub action, yeah. So let's
Supersonic hot tub.
polish it up a little and see. Nice. You can feel the air coming out on the bottom. Cool. So I used my dirty
You putting that in the cleaner too or not?
This one?
Yeah.
I can put it in there to get rid of all the machine residue. So let's take that. One of my favorite things. Take the boot off dashboard. These things are harder than hell.
What happens if you put it in the supersonic cleaner there?
Ultrasonic.
Ultrasonic.
Nothing. Just cleans it up. I can shove it in there. It's one unit.
Ugh. Yikes.
Good stuff. Let's take the whole thing and put it in there the way it is.
Do you want me to carry the
Piston, yeah, the thingy, and this one here.
no spring?
Alright, let's heated now, so I have to wait 20 minutes. I took the parts out now out of the bubble bath here, and as you can see, they came out really nice and clean. They looked kind of disgusting before. So now my beautiful new piston here fits in here nicely now. There's probably some. I can feel actually the air coming out on the bottom here. So that one fits in here. I have to put the
Spring.
Yeah, that one too. No, the how do you call it? We don't need a thing just to see if it works. So it's going up and down nicely. If I could reach in there, I could show it, but it's going up and down, as you can see. So I will check it out once I get all this things all cleaned up and put it back together with the new gaskets, which I apparently got. So that hopefully was a successful run of the first slide here. I will definitely check it out with vacuum before I make more, but unfortunately I have to do 2 more now, and then I can put it back together, I hope, and hopefully do my victory lap around the block and see how she runs. Till next time, let's see what we come up then on the next show here. Hopefully can put all these coverings together and make it work. So have a great week and keep on wrenching.